Yeah. All right, so an irregularly shaped stone was lowered into a graduated cylinder holding a volume of water equal to 20 milliliters. The height of the water rose to 30.2 milliliters. If the mass of the stone was 25 grams, what was its density? All right, so one way you can, so it purposely said, I'd like you to put this in the back of the page on your notes, right? Because this one is very much like, and you can put this, it's like homework problems number, who's got their homework handy? There you are. Nope.
Sorry.
Oh, okay.
6?
Oh, you will need that. Oh,
No, that's last. Like,
last one. Okay.
Number 6 is 10?
It's like number 10 and 11.
And 6. There's one like that.
Yeah, 6 is kind of like it, but they give it to you what the amount is. So 10, and this is like numbers 10 and 11. All right, so it notes that it's irregularly shaped because we couldn't use a volume formula. So we can't use, it's not a sphere, you can't use volume of a sphere, it's not a prism, it's in a regular shape. So it was lowered into a graduated cylinder holding a volume of water equal to 20 milliliters. So the height of the water rose to 30.2 milliliters. So the volume, so put this in your notes. So volume is equal to the starting level minus the ending, the ending level minus the starting level. Sorry, I wrote that backwards. The ending level minus the starting level. And this is an interesting way to spell level. Level. So it says starting. So this is for water displacement. And I'm all tangled in my cord. All right, so for water displacement, it's ending level minus starting level. All right, sometimes it just tells you it rose this much. That's your volume. But if it gives you values, then you have to find out you have to take the difference between them. So our volume here would be equal to the ending level was 30.2 milliliters. The starting level was 20 milliliters. And so that means the volume is going to be equal to 10.2 milliliters.
That makes sense.
Yeah. We're given the mass, got caught. Again, my jacket got caught in the cord. The mass is equal to 25 grams. The 0.0 really doesn't matter that much, but 25 grams. And so now our density is equal to the mass, which is 25 grams, divided by the volume. So it's 10.2 milliliters. So our density is going to be equal to,
It's a big number. Okay. Bless you. It's 2 point. Do you want all of it? It's really long.
No, we'll use part of it. So it's 2.45098 grams per milliliter. Right, so it's pretty dense stone.
Thanks.
Okay, so put this one in your notes. So we're going to do a real world density one here, just so you can see it in live.
That's what the water's for. I see. Don't drown the person. It's distracting. If you put the person in there, it's called recording.
Yeah, we won't be recording that. They can just see us finding the density. So I'm sorry that you're watching. I don't have a way for you to see us find the density of Mr. Bill. Yeah. I'll probably pause. I'll close the tape and I'll start up again on the next one.
can record it and
I
post it on YouTube.
I guess I could record. I guess I could just keep it going.
Yeah, boy. 25
It's only one question.
Yeah.
It'll be like the sports nuts here. Now we're soaking you in the water.
Yeah. Is everybody got
No.
this one? Okay.
May I ask you a quick question?
Yeah.
So to find mass, would that be volume over
A
density?
person could be drowning. and
So
you're
you'd isolate it, right? So you have mass over volume equals density. So if you multiply both sides by
not
volume,
allowed to say that. You can't have
you'd have mass. Mass would be isolated.
you have a professional opinion though.
Oh. Okay. So you use the same formula, which is isolate.
Right. So I have a scale for Mr. Bill here. While people are taking notes, we have the scale for Mr. Bill. Who's good at calibrating the scale and making sure?
We're all
All the eighth graders are?
Yeah.
Although,
Yeah.
here it's on this one. I'll have you guys do that honors. Here, if you want to do the measuring, because you're the closest, I don't have to pick it up.
Guys, don't splash the guy. Or you gotta like throw him in there.
You got to measure. Everyone knows who Mr. Bill is, right? Oh no, Mr. Bill! Saturday Night Live?
The builder. He looks cool.
No, not Bob the Builder. Saturday Night Live. You need to watch old Saturday Night Lives with Mr. Bill. And Mr. Sluggo would cut. So Mr. Bill is made of clay. It's not quite as obvious from here. So is Mr. Sluggo. And Mr. Sluggo would be mean to him. And he goes, and every time I see Mr. Sluggo, he'd go, oh no, he's going to be mean to me.
No, not that.
Is that the situation you're in?
155.4. So we're going to write down. So we're finding the density. No, you don't have to write in your notes. We're just going to do it together. Density of Mr. Bill. All right, so his mass was what again? 155.4 grams. This is his mass. We're going to find his volume now. So to find his volume, he gets dunked in the water. And however far the water level rises, that's his volume. So now, what's the, if you guys could, one of you could read the level, the starting level.
1,400 milliliters.
Okay, so we're starting off with 1,400 milliliters. Here's Mr. Bill.
Don't splash him in there. Oh, yeah.
He goes,
Gladly put this guy in the water.
Wait, can I put him in?
sure.
Dude, I said,
Rest in peace, Mr. Bill. May God-
There he goes. So Mr. Bill is in the water. How much did he raise it to?
1,500.
It looked like it was a tiny bit above, so you're going to have to estimate that.
1532.
Well, that's 13. 30,
See which one it was.
no, that's a little less. So probably.
What? You said a little more.
Round it.
1,500. Why does this guy?
Just say
It's like
1,500.
1,500. It's like, I don't know.
That's
1,525?
all right, 1525. Yeah, it was a little bit more. All right, so the ending level was 1525 milliliters. So now to find his volume, we take here the ending level minus the starting level. So that's going to be 1525 milliliters minus 1,400 milliliters, which means his volume is 125 milliliters. All right, so that's his volume. So now his density is going to be the mass, which is 155.4 grams, divided by his volume, which is 125 milliliters. What's Mr. Bill's density? 1.2432 grams per milliliter. Now, should Mr. Bill sink or float? He sinks. Why does Mr. Bill sink? Yeah. So why does Mr. Bill sink?
But the density is bigger than the mass.
Your density is larger than.
The water.
What's the water level? What's the water's density? 1. Yeah. So he sinks because his density is greater than the 1.0 grams per milliliter, which is the density of water. So he is denser than water.
He sinks right now.
Yes, you can see he sinks. But now we want to prove he should sink. His density is greater than the water, so he should sink.
He is sinking. He's probably gonna die.
And he's been rescued. He's okay. Mr. Bill is okay, yeah.
Throw me out. He's the drowning.
That's the end of this part of the tape, and so you guys can do the whiteboard practice on your own.
Throw me out.